Now that we've seen the overview of what regression analysis is about and how it's different from the time series forecasting methods, it's time to put on your seatbelt. We're going to have an equation or two, and we're going to talk about how you find that straight line which relates one variable, like temperature, to the one we're forecasting, which is like sales. So let's put that picture up again. We have temperature and we have sales, and we have some sort of, we've got a record of the simultaneous values of temperature and sales, and we're finding in general that on higher temperature days we have higher sales. So that's where we were before. We're going to call this the response variable, and we're going to call this the predictor. It sort of makes sense. So temperature is a predictor of a response, which in this case is sales. And we said that the essence of this approach is to find a straight line, which is a mathematical representation, which is trying to distill the message in this picture. This picture is called the scatter plot. This line is called a regression line, or a best fit line. The term regression has strange historical precedents back in the early 1900s. So this line, if you remember from high school algebra, a straight line has an intercept and a slope, and it has an equation. And so we'll, in general, call this y and this x. We're predicting y from x. And the equation is that y equals intercept plus slope times x plus error. In other words, there's still some variation around this line. It doesn't explain everything. It explains part of the randomness in the problem. And if we make this mathematical, we could say this is y is alpha, just some number, plus beta, another number, times x plus error, epsilon. This equation codifies the relationship between the predictor and the response. Alpha is a number, beta is a number, and x is all else, all the other factors besides x which have an influence on y. And those are responsible for these variations around the regression line. And so this is the general theoretical model. What we will actually estimate is that y is some particular calculated number a, the intercept, plus b, the slope, times x. And we'll say this is the prediction of y hat given x. So how do we calculate a and how do we calculate b? The computer, of course, will do that heavy lifting to calculate a and b, but the principle is very simple. If there's a particular intercept and slope here, if we extended this back to where the temperature is 0, this would be the alpha, and if we go up by 1 unit in temperature, the slope would be beta. So that's what they mean visually. How we would calculate it is, we would look at the actual scatter plot. Let me just approximate it again like this. This is our data, and we would try out different values of alpha and beta. For instance, if we said that straight line is a good summary of the relationship, we would say you're crazy. The intercept is too low and the slope is too high. It doesn't fit in the middle of the data. Likewise, this was also a very stupid line. It tilts the wrong way. But this line is probably pretty good. So the principle we use is to see which line comes close to the actual data points. And I'll erase this and start with a cleaner picture, and we'll just look at how we would calculate the intercept and slope.